Welcome. Today, we're diving into the world of event-driven systems, a modern approach to building software that's changing how businesses operate. Instead of relying on direct requests and responses, event-driven systems let different parts of an organization communicate by sharing events, facts about what's happening. This style is especially powerful for companies that need to scale, adapt, and innovate quickly. Throughout this video, we'll explore the core ideas behind event-driven systems, why they matter, and how Apache Kafka enables these patterns. Let's set the stage for a journey into streaming, collaboration, and the future of software architecture. As businesses grow, so does the complexity of their software. Traditional systems often struggle with direct, synchronous connections between services, leading to bottlenecks and outages. Enter streaming, a way to move data as a continuous flow of events. With streaming, companies can react to changes in real time, plug in new services easily, and keep their systems resilient. This shift isn't just about technology, it's about rethinking how organizations share information and collaborate. Streaming platforms like Kafka make it possible to decouple services, enabling teams to work independently while staying connected through shared data streams. Apache Kafka is at the heart of many event-driven architectures. But what is Kafka, really? Think of it as a central nervous system for your organization, a platform that collects, stores, and distributes streams of events at massive scale. Kafka isn't just a messaging system, it's a durable, scalable, and high-throughput backbone that connects everything from microservices to analytics. With APIs for stream processing and connectors for databases, Kafka turns static data into a living, flowing resource. This makes it easier for businesses to innovate, adapt, and build robust systems that can handle anything. Let's peek under the hood. Kafka organizes data into topic streams of events that can be read by many services. At its core, Kafka uses a partitioned log where messages are appended in order and stored across multiple machines for fault tolerance. Producers write events to Kafka, while consumers read them at their own pace. This design allows for high throughput, strong ordering guarantees, and the ability to replay history. Whether you're building a real-time analytics pipeline or synchronizing microservices, Kafka's architecture makes it possible to scale effortlessly and keep your data safe. In event-driven systems, events are the universal language. They represent facts like an order being placed or a payment processed. Unlike commands or queries, events don't expect a response. They simply announce what happened. This approach reduces tight coupling between services, making it easier to add, remove, or change components without breaking the system. Events can be used for notifications, data replication, or even driving entire workflows. By focusing on events, organizations can build systems that are more flexible, resilient, and ready for change. One of the biggest advantages of event-driven design is loose coupling. Instead of services directly calling each other, they communicate by publishing and subscribing to events. This means new services can be plugged in or removed with minimal disruption. For example, if you want to add a repricing service to your e-commerce platform, you simply subscribe it to the relevant event streams. The original services don't need to know about the new addition. This pluggability makes it easier to evolve your architecture as business needs change, supporting innovation and reducing risk. Not all event processing is the same. Some services are stateless, they react to events one at a time, often looking up extra data as needed. Others are stateful, maintaining local copies of data or joining multiple streams together. Stateful stream processing, enabled by tools like Kafka Streams, allows services to hold tables of data, perform joins, and keep everything in sync with the event log. This approach boosts performance and autonomy, as services don't need to make constant network calls. However, it also introduces challenges around managing state and recovery, which Kafka helps address with features like standby replicas and changelog topics. Event sourcing is a powerful pattern where every change in the system is recorded as an event in an immutable log. Instead of just storing the latest state, you keep the full history, making it possible to rebuild state, audit changes, and recover from errors. CQRS, or Command Query Responsibility Segregation, takes this further by separating the write and read paths, commands, write events, and queries read from materialized views built from those events. Kafka makes implementing event sourcing and CQRS practical at scale, providing durability, replay, and the ability to create multiple views for different use cases. With event streams as your source of truth, you can build as many materialized views as you need, each optimized for a specific use case. For example, you might have one view for fast key value lookups, another for analytics, and a third for full-text search. These views can be built using different databases or technologies, a concept known as polyglot persistence. Kafka's replayable log makes it easy to bootstrap and update these views, ensuring they stay in sync with the latest events. This flexibility empowers teams to choose the right tools for each job without being locked into a single database. Kafka's architecture is built for scale and reliability. By partitioning data across many machines and replicating it for fault tolerance, Kafka ensures your events are always available, even in the face of hardware failures. Features like quotas help manage bandwidth in multi-tenant environments, while compacted topics keep datasets manageable by retaining only the latest version of each key. Whether you're a startup or a global enterprise, Kafka can handle workloads of any size, making it a trusted backbone for mission-critical systems. Let's bring these ideas to life with a real-world example. Imagine an online store where customers place orders. Each order triggers a series of events: order created, payment processed, item shipped. Different services handle each step, collaborating through events. If you want to add a new feature like sending a confirmation email or updating inventory, you simply subscribe to the relevant event stream. This modular, event-driven approach makes it easy to extend and maintain the system, even as requirements evolve. Event-driven systems are more than just a trend, they're shaping the future of software. By embracing events, streaming, and platforms like Kafka, organizations can build systems that are scalable, resilient, and ready for whatever comes next. Whether you're modernizing legacy applications or designing new services from scratch, the event-driven approach offers a path to greater agility and innovation. As we wrap up, remember, the truth is in the log, and the possibilities are endless when you let your data flow.